Hello students, as we have read in the previous class that there exist electric charges and these electric charges produce sparks, and then we have read about the concept of electrostatics as these charges are static in nature, and being static they show these kind of properties. Okay, now today we will learn what are electric charges and how these charges are being accumulated on the surfaces, let it be a conducting surface or an insulating surface. Okay, so how these are being accumulating, we will read that also. Okay. So starting the class, historically when we see it was long days back around 600 BC, before the birth of Christ, uh, Thales of Miletus, Greece. So like a person belonging to Greece has discovered a fact, like it was basically coincidental. Mostly the discoveries made in history were all coincidental. So the Thales, he used to observe, and he observed that when we are rubbing a woolen or a silk cloth with umber, umber is a kind of stone, okay, kind of stone, and we are rubbing this stone is kind of transparent, and when we are rubbing this woolen or silk cloth, and then after that if we bring this umber near the light objects, these light objects get attracted to it. So just take an example, this is our umber and this is our cloth, woolen or what, or silk cloth. Okay, so we rubbed this umber with our woolen cloth. Now this umber is brought near the small bits of paper or small polystyrene balls, and now these are getting attract to it. Okay, so this when he made this kind of observation, it came to his brain to give some terminology to these kind of attraction, and he then gave name electricity. That umber is able to generate some kind of electric charge, which he stated as electron. Okay, electron is a Greek word which means umber. In Greek, umber is said to be electron, and from this electron we got the term electricity. So what is electricity? The electricity is the flow of charges which we are able to see in our household light and fan fittings, the mixie we use, the fridge we use, everywhere this electricity, this motion of charges, the motion of electrons play a very important role. Okay, now how these, like we have seen a pair of wool and silk and umber, right? Wool or umber first rubbed, or silk or umber rubbed, umber gets electrified and start attracting the light objects. Similarly, which all pairs are present in general our day-to-day life, which on rubbing gets electrified and start attracting the objects, the smaller objects, the lighter objects. That electric charge which is acquired by rubbing is not that huge that they can attract a bigger object. So it's a very small charge which is just sufficient to attract the light objects. So see over here, pairs of material which on rubbing attracts objects like straw, pith balls and bits of paper, because these are extremely small, light weight and can be attracted using very small charges, very small accumulated charges. So first of all, to know the validation of this attraction of charges and all, we will do one experiment. Maybe right now many of us are reading, watching this video using a mobile phone. So you might be having a page, a paper, A4 sheet or a normal rule line paper in front of you on which you are taking up the notes. So you can just cut down a very thin stripe of it, extremely thin stripe, and then bring this stripe, like first of all iron this stripe, keep it on a table and iron with your even your hands. It should just be hot, or if you will iron it with your hand, then the charges will not accumulate. Use something like iron. You can simply go with the iron box or any other material which is made up of iron. And after ironing it, bring this paper stripe near your mobile phones or laptop screen or TV screen. Okay, once you bring, find out the observation. Okay, but we will not wait till that point. We will go directly to the observation and we will see that this stripe gets attracted to the screen. Screen of what? Whatever you are using, let it be a computer monitor, let it be a TV screen or your mobile phone. It gets attracted to it. It starts stucking and it remains stuck to the screen for a while, not for a very long time, but for a while it will be stuck to the screen. So this is one example where shows that this white stripe of the paper after ironing accumulates some charges on it, and when brought near the screen of television or screen of laptop or our mobile screen, which have lots of moving electrons, these two starts attracting each other. These two starts attracting each other. So how is it happening? It's just because charges are being accumulated over this paper stripe. Okay, so this is our observation from our paper stripe and mobile screens experiment. Now we are taking two particular cloth, one is silk, one is woolen, and then we are taking two other pairs of the rod. One is plastic rod, one is glass rod, and we will see how these two are behaving. Okay, so you can see here the diagram. This is our silk thread which is tying up our rods. There are two rods, glass, plastic, and plastic glass. Okay, all these rods are being hanged by a silk thread. Why we are using silk thread? Because this silk thread along with this insulated, see here, insulated holding cup will insulate the whole system and will not allow the charges to move here and there, and hence our experiment will go smoothly. In case we are using any other conducting body to hang our rods, then we will not get the desired result. Okay, and then see here the second diagram. There is repulsion in this. In this there is again repulsion. But what about here? Here these two bodies are being attracted to each other. Then how it's happening? So let's move on to the next slide to understand what basically is happening and how we are getting repulsions and attractions. Okay, so pay a little attention. So what we are having wool, silk, and a plastic rod and a glass rod. So a glass rod, a plastic rod, and this is our glass rod. Both are glass rod which are brought together. These are our plastic rod which are brought together, and here this is our glass and this is our plastic rod, two different rods. This is just a rough representation of previous two figures. Rough representation. Okay, these are glass rod, these are plastic rod, and over one is glass rod GR and down one is plastic rod PR. And what kind of things relation they are showing over here is repulsion due to negative charge, repulsion due to positive charge, and attraction due to two different charges. Okay, so we are having one woolen cloth, here also woolen cloth, other cloth is silk cloth, here also silk cloth. Okay, so we are rubbing our glass with woolen cloth and we are rubbing our glass rod with silk cloth. Similarly, the plastic rod is also been rubbed with woolen as well as silk. Now the two glass rod which is rubbed by silk is brought together with a glass rod which is rubbed by wool. Okay, see, this is our glass rod which is being rubbed by woolen cloth and silk cloth. In both these cases, they acquire same charge, Now, in the second case, we are having plastic rod which is rubbed by silk cloth and the other is again plastic rod which is rubbed by woolen cloth, and they both acquire same charge again, same charge. So in either case, if it's a silk cloth or a woolen cloth, both give similar property to a glass rod and similar property to a plastic rod. So here this plastic rod is having all the positive charges, but both the plastic rod 1 and 2 both are having same charges, hence there is repulsion. Negative negative repels, positive positive repels. But a glass rod, this is the third case, a glass rod which is rubbed either by silk or woolen or wool is brought near to a plastic rod which is rubbed by silk or wool, they acquire different charge, and hence these two rods attracts each other. Okay, so this is the case in the figure 3. In the figure 3 you can see one rod is having positive charge and other rod is having negative charge. As these two charges are different, these two charges are being attracted. So from this whole experimentation of plastic, woolen, glass, silk, what we conclude is we conclude that like charges repel and unlike charges attract each other. Further, we will keep on doing experimentation to know the type of charges and why there is attraction or repulsion, so forth. So here see, the plastic rod attracts the glass rod and repels the silk or wool with which the glass rod is rubbed. Glass rod repels fur. Here we are talking about cat's fur. When a plastic rod rubs with fur, it's made to touch two small pith balls. What we are doing, we have taken a plastic rod. And rubbed it with fur, and then we kept our pith balls around the plastic rod, polystyrene balls. Okay, these pith balls are made up of polystyrene, so we can call them polystyrene also. And this plastic rod is suspended by silk or nylon thread and is kept into the insulating cup to handle it. Then we have seen that these two polystyrene balls repel each other after coming in contact with the rod. Okay, now plastic rod with fur and pith ball, the pith ball gets electrified. Pith ball 1 and pith ball 2 gets electrified by the plastic rod. Like plastic rod is having one kind of charge, and that same kind of charge is delivered to the pith ball 1 and pith ball 2. So both will have same kind of charge, and as we have seen in the previous slide, if they are having same charge, what will happen? Repulsion. They will show repulsion. Okay. A similar effect is found if the pith balls are touched with a glass rod rubbed with the silk. If we are taking a glass rod, rubbing it with the silk and bringing the pith ball near, the same behavior it will show, because if though this glass rod is having a different charge, different polarity of the charge, still the pith balls are getting the same charge. Once they are brought together, they will show repulsion. A dramatic observation is that the pith balls touched with the glass rod and touched with the plastic rod attracts each other. See, this is our pith ball 1, this is our pith ball 3, this is rubbed with plastic rod, PR is plastic rod, this is rubbed with glass rod, GR. Now these two are brought together and they will start attracting each other. What will happen? Attracting each other. Okay. So from this one experiment, from the pith ball, plastic and glass rod experiment, we made few observations and we concluded these observations. Okay. We made few observations and we concluded these observations as only two kinds of an entity which are present, which is called the electric charge. What is electric charge? Electric charge is something which is present only two kinds of entity, only and only two kinds of entity, no, not any third party available in this case. And from the same experiment, we concluded that like charges repel each other and unlike charges attract each other. Like charges repel each other and unlike charges attracts. Okay. This is extremely important to understand how these electrons, protons and nucleus are behaving in an atom. So one should always and always remember, when we are talking about same polarity of a charge, same polarity of a charge, it will repel, it will show repulsion. If you are given milk in the breakfast, in the lunch, in the dinner for like too many days, what will happen? You will start hating the milk. Your like brain will start repelling taking the milk. You will be like, for all the 4 times of meal I am getting milk, and now I do not want to have more milk. Your brain will start repelling. But on the other case, if we have different polarity of charge, different polarity of charge, what will happen? They will start attracting. Now we can see this attracting force through another example. You are reading storybooks. You have a very good habit of reading the stories, and you started reading, but your parents did not allow you to buy the new books. You are reading the same story from last 10 days. So after 15 days, what will happen? You will be like, oh, I know this story. You will get bored and you will stop reading the stories. The passion in you to read the stories will die off. So that is repulsion. Whereas you love reading the storybooks and your parents are providing you storybooks on a daily basis. Every day they are getting a new book for you which is having a new story, and in every new story you are learning something new. So whenever you read a story, you aim at reading more, you aim at exploring more. So next day you get something to explore, and as this goes on for so many days, what happens? You start getting attracted towards the world of novel. You start attracted reading these different stories, these different concepts. So same thing happens in the world of charges also. When it comes to only electron which is negative charge, they will repel each other. But when it comes to electron and a proton pair, they, what they do? They will attract each other. So remember, in a very simple and sober statement, like charges repel and like attracts. Now this property which differentiates the two kinds of charges is called polarity of charge. Like in the upcoming sections we will read about the charge contained in a electron and in a proton. The amount of charge contained by electron and proton is same. They both have this charge value equals to 1.6 into 10 to the power minus 19. But what makes the difference? What is making the difference in these two charges? The thing which is making the difference is the polarity. When we deal with electron, polarity is negative. It is given as minus 1.6 into 10 to the power minus 19. And when we are dealing with proton, the same charge is given as plus 1.6 into 10 to the power minus 19 coulomb. So the polarity is the one thing which is making the difference between the two kinds of charges. The charges which acquired after rubbing are lost when the charged bodies are brought in contact. So when we are rubbing one body, okay, we are rubbing one body, and what happens after some time? It will start accumulating the charges. Once these charges are accumulated, what happens is that these charges will stay there, as we are dealing with electrostatics. Now we brought a very uncharged body to this charged body. See, this is our charged body which is charged due to rubbing, charged by rubbing, charged by rubbing, okay. And now we are bringing this spherical body which is extremely uncharged, like a malnourished human, okay. uncharged. What will happen? This body will start giving its charge to this spherical body. This rod will start giving its charge to the spherical body and hence making the rod uncharged. It concludes that unlike charges acquired by the object neutralizes or nullify each other's effect. Therefore, charges are named as positive and negative by American scientist Benjamin Franklin. If an object do not have any charge, it is said to be electrically neutral. Here the term electrically neutral is really a tricky term. So we will understand how this term is tricky. First thing which we need to note down is the names to the polarity of charges was given by Benjamin Franklin. Now see over here, Benjamin Franklin. He was an American scientist. He worked in the field of electrostatics and electric currents, and he gave us these charges, positive and negative name to the charges. One have the positive polarity, other one is having the negative polarity. Now moving on to the electrically neutral bodies. Electrically neutral body does not imply that charge on a body is zero, but it implies that charge which is having negative polarity is equal to charge which is having positive polarity on the body. A body will always have some charge, will always have some charge, but the amount of charge present in the negative number will be equal to the amount of charge which is present in the positive number. Okay, if this body contains three negative charges, then to make this body electrically neutral, we need to add 3 positive charge to this body. Okay, any electrically neutral body is not a body with charge equal to 0, but a body which is having equal number of negative charges and equal number of positive charges. So make a note of it. Electrically neutral body have charge on it, but the polarity of charges are balanced well. Now this is quite an interesting topic over here, gold leaf electroscope. So gold, something made up of gold. Okay, the name says something made up of gold. Gold is scientifically called orium. Okay, and gold is electrically inactive. It behaves like insulator. It is a metal but behaves as insulator. It do not conduct. Insulator, a very inactive metal, and hence you have seen we wear gold as earrings, as necklaces and whatnot. Like we make a lot of jewelry out of it because it is very rare to get an electric shock. Very rare. It's not rare, it's impossible to get electric shock through gold. Okay, so gold leaf implies what? Leaves. You have seen the trees, they have leaves, right? So leaf is that leaf kind of structure. The gold is turned into leaf like structure. And electroscope, electro implies something related with electrons or something related with charges, and scope tells something which deals with number or amount. So what the term gold leaf electroscope basically means is a device or a apparatus which is having leaves which are made up of gold, and it is used to detect number of charge or number of electrons in a system or on a body. So defining this gold leaf electroscope in a single line is a simple apparatus to detect charge on a body. A simple apparatus to detect charge on a body. How do we construct a gold leaf electrometer? See the statement over here. Gold leaf electrometric scope consists of vertical metal rod housed in a box with two thin gold leaf attached to its bottom end. Come to the figure here. See it. We are having a box which is having glass windows to peep inside. Inside we have a scale here. Inside we have a scale over here. Why do we have a scale? I will explain. So this is our box. On this box we have made a hole over here. See, this is our hole, and through this hole we have introduced a metal rod. We have introduced a metal rod which is conducting in nature. Okay, which is conducting in nature. If this is not conducting in nature, how will these charges will go from this rod down to the leaf, This is our rod, see here, and these charges from a charged body, the charged body whose charges is to be known. So I will write it as a charged body only. This is a charged body whose charge we need to know using a electroscope. Okay, so along this rod down, the electrons need to move in order to show the effect on gold leaf, Okay, so for providing a proper movement to electron, this rod should be conducting in nature, Okay, so this is metal rod. On metal rod we have a metal knob near which we bring our charged body whose charge is to be known. At this end, see over here, I will make it using a dark blue color. See this box. In this we can see leaf-like structure like this. Okay, this is leaf-like structure and made up of gold. So this is the construction. Now the next question arises is, how does it work? Basically what we do, the body whose charge, we want to know how much charge that body is having. We bring that body near this metal knob, and from this metal knob the charges start going to metal rod. From metal rod it gets conducted to gold leaf. As I have told, this rod is conducting in nature, hence these charges get conducted to the gold leaf, and this gold leaf, these two parts of gold leaf start accumulating same amount of and same polarity of charge. Same amount and same polarity of charges. Okay, so when it is same polarity of charges, what this gold leaf will show? They will show repulsion. What they will show? They will show repulsion. Okay, these gold leaf will start moving apart. This gold leaf will start moving apart. See here, they are both having positive and equal charges, and they are showing divergence. Now come to the statement of working over here. When a charged object touches the metal knob at the top of the rod, charges flow on the leaf and they diverge. What are the results we are getting through this experiment is that degree of divergence is an indicator of amount of charge in the body, charged body. Okay, now what is this? This is a self-made electroscope. Self-made electroscope. Okay, then how does we make an electroscope? What we have done is, we have taken a jar which is transparent. First of all, we introduce the paper scale at the bottom of this transparent jar. Then we took a cork and fixed on the neck so that air or some other unwanted charges doesn't go inside. We fixed a cork. Okay. Now we took a aluminium sheet, the aluminium sheet in which our mother packs food for us. We can take that one also. We say it aluminium foil. We took it and we made a rod out of it by multiple foldings. By multiple foldings, we made it a stick and we made a hole in the cork and introduced this stick over here. See. And below the stick we cannot bring gold because it's quite expensive and bringing it for an experiment is really worthless. So what option we have? The other option we are having for making these leaves, for making this leaf is aluminium foil itself. Aluminium foil itself. We will take around 6 centimeter length of aluminium foil and 1 to 2 centimeter of width, and cut it into small pieces and fold it from between, and then we will make something like this, these leaves, which we will attach over here. Now in the similar way working will be there, the way working was there for this one. We will bring a charged body near the other end of our aluminium rod, which is around 2 centimeter long, and then these charges will start flowing to this aluminium rod, to these aluminium curtains, and then these curtains will show divergence, and the shown divergence will be calculated using this paper scale which we placed in the down side, and hence we will get how much amount of charge is present in the given body. So this is the homemade experiment. You can make it at your home easily with all the things available in the kitchen of our mother. So this is how we determine electric charges. So here we will see why material body acquire charges. All matter made up of atoms or molecules. So whatever matter we are having in a system are made up of atoms and molecules. This is our basic. The fundamental unit of anything is atom. Atom is indivisible unit of matter. Undivisible unit of matter. Okay. Normally materials are electrically neutral. It's not like they do not contain charges, but their charges are exactly balanced. As I have explained in the previous slide, that bodies tend to be electrically neutral, but the charge on the body is not zero. Rather, positive charges are equal to negative charges. Forces that hold molecules together, forces that held atoms together. In solid, adhesive forces of glue, forces associated with surface tension, all are basically electrical in nature. All these charges have electrical base, okay, and arises from the forces between charged particles, and these are arising due to the charged particles present in that system. Therefore, electric force is all pervasive and it encompasses almost each and every field associated with our life. Electric forces are very much important, are pervasive in nature, and they are associated in each and every activity of our life. To electrify a neutral body, we have to add or remove one kind of charge. Like we are having a body having so much of charge, but still it is electrically neutral body. What we will do, either positive or negative charge we will start removing. Okay. Now what will happen, inside the body we will have more number of other charge, opposite charge. We will take example, we have a body here and we removed positive Q charge, then there is excess of negative Q charge. So this makes this neutral body negatively charged, negatively charged. In the other case, what we can do, we can give that body a single kind of charge. Again we are having a neutral body here, neutral body, and we started giving this body all the positive charges we have. Now this body have excess of positive charge, excess of positive charge, and hence this will be termed as positively charged body, positively charged body. Okay, so see this statement over here, when it is solid, a body is charged, it refers to excess or deficit of a charge. Either the charge is in excess or the charge is deficient in the given body. By losing some charges, body can be positively charged, and by gaining some charges, body can be negative charged. Here we are talking about the electron. By gaining some electron, it will be negatively charged, whereas by losing some electrons, it will be positive in nature. This is similar as ionization happens in chemistry. Ionization, which happens in chemistry's chemicals, chemical molecules and atoms. Okay, it's similar as this. Now glass rod which is rubbed with the silk, some of the electrons transferred from the silk cloth to glass rod. As you have seen the diagram, this one I have made negative, 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 and these are showing negative and negative, and hence repulsion. So what was done here, like negative charge electrons were given to glass rod by silk cloth, This is exactly what happened, and hence the glass rod got negatively charged and they were showing the repulsion. Thus the rod gets positively charged and silk gets negatively charged. No new charge is created in the process of rubbing. This is very much important. In the upcoming classes we will understand why it is that important, but make a note over here. In any process of rubbing, no charge is created and no charge is destroyed. How can we say this? This is basically the law of conservation of the charges, and this happens because when we are rubbing a silk cloth with glass rod, basically the glass rod gets charges from the silk cloth. It is not like that on rubbing these will start getting the charges from somewhere else or start making the charges. No, there is no making of charges or no destruction of charges. It's just a process of transfer from here to there and from there to here. Okay, so that is all for today's class. In this class what we have read basically is like what are the charges, what type of charges are available, what is polarity of charges, what is a electrically neutral body, and then why do the body acquire charges, and how did we found out this polarity of charges. We did some experiment on it, and hence in the last we understood that charges are neither created nor destroyed in the process of rubbing. So hence these charges are being conserved. The charges have conservative property, conservative nature. So here our today's class ends. Let's meet in next class. Bye bye.